So this lesson is on solving quadratics. So lesson is on solving quadratics. There are a lot of different ways to solve quadratics, and it kind of depends on what format it's written in, and you want to like get good at picking what would be the best method based on what you've got. Real quick mini lesson before we go into solving on imaginary numbers, perfect squares and imaginary numbers, because you need to know that in order to solve, because sometimes your answers come out to being imaginary. You did learn it in Algebra 2 though, so it's just going to be a real quick review. Without a calculator, I expect you to know your perfect squares up through 12 squared, okay? What is your first one? One. And do not forget about 1. 1 throws everybody off. The square root of 1 is 1. 1 squared is 1, so don't forget about 1. All right, and then 4, I'm hoping we can just shout these out real quick. 9, 16, 5, 36, 81, 121. Now, if you know them more, because I think you know them up through like 20 or whatever, that's cool. My expectation is without a calculator, you'll know them through 12. Fair?
Yeah.
Okay. So your imaginary number is I. Please be very deliberate with dotting your I's, otherwise they will look like ones. And we defined I to be the square root of -1. It's the way that you get a negative underneath a square root so that you can get an actual answer. But you do the problem just like before, you just throw an I into the answer. For example, if I cover up this negative, what's your square root of 100? 10. With the negative in there, it makes it 10I. It doesn't make the answer negative, it makes it imaginary, okay? For example, what would be the square root of -16? 4I. Good. It doesn't make the answer negative, it makes it imaginary. All right, now if your number's not a perfect square, you have to split it apart. The first thing that you do is you take out an I. Sounds really violent. You're going to take out an I. You take out the negative part, draw 2 little houses, and I need for you to come up with 2 numbers that multiply to be 8, but one of them has to actually work. Good. Perfect. And then what I do is I cross them off as I reduce them. What is your square root of 4? Because that was like the whole point of choosing that. 2. So cross that off. That's 2. This part turns into I. And then you will have something that's left over. It's kind of like, well, we did good enough. We reduced everything we could. That square root of 2 is going to just stay. Do you remember this from Algebra 2? It's like everybody's least favorite unit, all the roots and everything. We're going to do the basic simple ones, though. We're not doing like cube roots, and we're not doing anything like real weird with I. Like, we're doing the basics of it. Yeah, go ahead. It is. I think Miss Colville does it as a self-taught. Yeah. So you like go at your own pace.
I love
that idea. Oh, you like that?
It was so good. Like I learned so much.
Oh, good.
I had like 7 blocks to do it on, and I put it on 3, so then I had 4 free blocks.
That's nice.
No, I did not do mine like that.
All right, again, we're gonna do like real basic stuff with it. We're not gonna do the whole everything you did last year. The first thing that you do is you take out an I. You take out the part that's negative, draw 2 little houses. Now you need numbers that multiply to be 48. But one of them has to actually work, and it has to be the biggest one possible. Try again.
Well,
it is 16 times 3. 16 times 3 gives you 48. So all those other numbers you guys were throwing out, those go into 48. But you need one of them that's a perfect square. Like you need one of them that's going to actually work and take you somewhere and not be a dead end. So like 12 goes into 48, but you can't square root 12, but it's not nice. All right, what is your square root of 16? That's kind of the whole point. It was 4. And then the -1 part is the imaginary part, so that's I. And then square root of 3 is sort of just left over. Let's try one more of those. All right, take out the negative. You're going to take out an I. Draw 2 little houses. What multiplies to be 45? 9 times 5. So again, just as an example, like 15 times 3 as well, but why wouldn't you want that? Yeah, you need a number that's going to actually, you need a perfect square. So what is this going to reduce down to? Yep, 3I Square root of 5. Cool. All right, so that was your little mini lesson on imaginary numbers. That's all we're gonna do with them. You just have to be able to square root negatives is all that it is. All right, so again, there's a whole mess of ways to solve quadratics. So I have like a couple of each method here. So first we're gonna do graphing, which is where you make a graph and then basically just look at it, all right? So using words like up, down, left, right, how did this get shifted? Up 8, good. So you're gonna count 8. It might be right on the edge of the grid. 1, 2, 3, 4, 5, 6. Oh, yep, it's right on the edge there. But that's okay because which way is this gonna be facing? Downwards. Let's have a collective focus back there, right? It's gonna be facing downwards. I'm gonna make a little table of values. If you're like, nah, Miss Cole, I can do it in my head. That's cool too. I'm never gonna grade your table of values, but it helps, all right? What do you want to try and plug in? You can plug in anything you want. Doesn't work, we pick something else. So we already did 0. That's a really good number to plug in, but we already did 0. We got 0, 8. So yeah, so 1. Let's do 1. All right, ready? Here's what you got to be able to do without a calculator. 1 squared. 1 times -2 is -2 plus 8, 6. So you get 1, 6. And then because it's a parabola, you get the buy one, get one point on the other side. Let's plug in something else. What else do you want to try? 2 is a good option, all right? Plugging in 2. 2 squared. 4 times -2 is -8 plus 8, 0. And then again, you get the buy one, get one point on the other side. And then you just look at it and you go, oh, there are my answers. Now you need to know which part you're looking at. When you solve a quadratic, what you're finding are the x-intercepts. And actually, we have a few other words for them as well. I'm going to go over that in just a second. I want to make sure you know all the vocabulary. So we got 2 answers. What are they? X equals, yep, -2 and 2. And whoever said 2, 0, you're fine. When we write our answers, it's okay to write x equals, and then that's fine. Let's review what else they're called, though. Maybe I'll just write this off to the side. They're called x-intercepts. Good. They're also called zeros. Does anyone know what else they're called? We have like a lot of words for the same thing here. One begins with an R. Roots, good. And then the last one is solutions, which means like answers, like the answers to the question. But those all mean the same thing. You're finding where the graph touches the x-axis. So let's do one more with graphing. I get that if I give you a choice of which method to use, you're probably not going to pick graphing. You're probably going to do anything else besides graphing. So I won't torture you too much. We'll just do one more. Now, the first thing you need to do is make it equal 0. I call this evacuate. That's what I always call it. Evacuate, evacuate. It means slide everybody to one side so it all equals 0. Like get everybody to one side. So we're going to add over the 9. So before you do any method, you have to evacuate. That's always the first step. And then I want to write this as blank squared. So I did do a warm up. Do you remember what is going to go in the blank? Good. X minus 3. So using words like up, down, left, or right, what direction did that shift? Right 3. It didn't go up or down at all, did it? Yeah, so right 3. And is it facing upwards or downwards? Upwards. And you could get more points if you want, but I really don't need to because the whole point is where does it touch the x-axis? And we actually only get one answer here, which is just 3. It is called a double root, though, because it was a twin. So you can actually write x equals 3 twice, and that's fine, too. But once is okay for it. So that's graphing. Again, I get that if I give you a choice of method, you're probably not going to choose graphing. No one's like, hey, I was going to choose to do graphing given my own, option. So now we're going to do factoring. See what you remember from algebra 2. First, evacuate. Slide everybody to one side. You're going to add the 4x squared, but you want to be clever about where you write it. Where should you put that term? Yeah, in the beginning. Good. You want it to be the x squared and then the x and then the number. So what I'm going to do is pause the recording real quick and give you guys a chance to give that a shot. Recording. So you can either split this 2x and 2x or 4x and 1x, and you kind of just guess and check it. But it will end up being the 4 and the 1. Now, what multiplies to be 2? 1 and 2. Now, it does matter where you put them. Do you want the 1 in the first parenthesis or do you want the 1 in the second parenthesis? Okay, now here's where we check. Guess and check. We guessed, now you have to do the check part. Watch me point to this. What do the outsides give you if you multiply these? 8x, good. And the insides, 1x. Will 8x and 1x get you to the middle number? Yes. What symbols do you need? Minus. -8 and -1 gives you -9. Now, don't stop there. That's such a sad day. I have to mark it wrong because we're not finished yet. You have to actually get your answers. Now, I'm going to talk you through this. If you want to write it for right now, that's fine. I'm hoping you can get to the point where you can kind of make the leap and not have to write it out. We'll do this one first. If you set x minus 2 equal to 0, what should x be? Yeah, 2. 2 minus 2 is 0, or you could think of adding over the 2. Now, if you set this one equal to 0, it's a two-step problem. First, you would add over the 1, and then what would you do? Yeah, divide by 4. So if you add 1 and then divide by 4, you get 1/4. Cool. Draw your two parentheses over here. We don't have to evacuate because it already equals 0. I'm going to pause again and let you try this one. So how would you split up 16x squared? Did you say 4x? Okay, a lot of people talked at the same time. All right, then how would you split up 49? Okay, now there's nothing in the middle, which means it's 0. 0x, no x's. So what symbols do you put in here to get it to like cancel out? Yeah, 1 plus and 1 minus. And that's how you end up with 0 in the middle. Now, hold on, you still need to get your answers. If you set this first one equal to 0, what would you do to both sides to solve it? -7, so -7, and then divide by 4. And then this one, you would add 7 and divide by 4, so +7/4. Good. We'll do a couple more, and then we'll do like a halfway break. It feels like we're still good, like nobody's fading out on me, so we'll do a couple more. We'll do the next property. Yeah. Pre-calc, the first half is largely a review of Algebra 2, but without a calculator and moving a little bit more quickly. Yeah, so you're prepared. All right, now this is solve using the square root property. Just means solve. Here's what the square root property is, though. I need for y'all to listen. When you square root something, you have to put plus and minus in front of it. For example, your square root of 64 would be plus and minus 8. Are you with me there? The reason why is, for example, what is 8 squared? 64. And what is -8 squared? 64. They both work, so you need the plus and the minus. So that's what this property is when you square root, you have to put a plus and a minus. Just remember, you're going to get 2 answers. Other than that, you're just solving. How would you move this 5 to the other side? Yeah, divide both sides by 5. This is just regular old algebra, like solving an equation. Just divide by 5. You get x plus 2 squared equals what? 6? And then you want to get rid of the squared. So you're going to square root, and that means you need to put plus and minus. That's what that property means. So you get x plus 2 equals plus and minus square root of 6. Square root of 6 does not work. 6 is not a perfect square, and you can't split it. If it's one that you could split, like we practiced doing over here, then you need to do that, okay? But 6 is too small of a number. Nothing else is going to work. And then what's your last step? To get x by itself. Okay, now listen. You do not want to write the -2 at the end. Don't write this. I'm going to end up erasing this. Can you see a problem with putting the -2 at the end? Like, what could it potentially look like? Do you see how it might look like it's underneath the square root? So here's what we do instead. When you subtract that 2 out, or excuse me, to the other side, when you subtract that 2 to the other side, you put it first. So it's -2 plus and minus square root of 6. So just write it out front. That's the format of how we write it. How many answers is that? 2. You got -2 plus square root of 6, and you got -2 minus square root of 6. So it is 2 answers. Let's try it again. What would you do to start solving this one? It says solve using square root property. So that's not like wrong, but the directions say something different. Thank you. -64. I heard people saying the other steps were just not there yet. So subtract 64, we would get 2x squared equals -64. Divide by 2. Good. Perfect. So x squared equals -32. And then last step, square root. What do we put in front of it? Plus and minus. Good. Now this one you have to split apart. What do we take out first? Good. Take out an I. And then draw 2 little houses. You need numbers that multiply to be 32, but one of them has to actually work. Like you don't pick a dead end number. I heard somebody whispered over here. Good. 16 and 2. If you were like, hey, Miss Cole, what about 4? You want the largest one possible. So 16 is the biggest one that's going to work. So it is x equals plus and minus. How is that going to reduce down? 4i square root of 2. And again, how many answers is that? 2 answers. One's the positive one, one's the negative. So these next 2, it says solve by completing the square. That's the lesson that we did last time. So we're going to, use what we learned last time. We're going to have to do a little bit of rearranging with this first. I need to bring this 2x over. So I'm going to write it as x squared minus 2x. It's negative because I subtracted it to the other side. You're going to leave a little gap and put equals -10. Where did I get a -10 from? Yeah, subtracted the 10 to the other side. So do you guys see how I just swapped those? Okay. Now here's where you complete the square. What is going to get added on here to complete the square? Good. 1 is a tricky number. It does mess people up because 1 squared is 1. Now, if you add that to the left side, you have to add it to the right side. You take 2, divide it by 2, and square it. It's divide by 2 and square. And the whole point of that is you can now write it as blank squared, and what's going to go in the blank? X minus 1. Good. And then on the right side, -9. That's what we did last time. Now we're just going to finish it up. So just keep going. How do you get rid of a squared? Square root. So you get x minus 1 equals what? You really get plus and minus. Perfect. Thank you.
Plus minus 3i.
3i. It's imaginary because of the negative. And then you have one more step. What's your last step to get the x alone? Plus 1. Now, yeah, thank you. We usually write it out front. So it's 1 plus and minus 3i. How many answers is that? 2. It's 1 plus 3i and 1 minus 3i. Quick other follow-up question though. If both of the answers are imaginary, if you were to actually graph it, would it touch the x-axis?
No.
No, because the answers are imaginary. All right, this one has a 3 out front. We're going to factor out the 3. The most common mistake, don't write this. This is the most common mistake, is that people will put that. What's wrong about that? Yeah, both of them, okay? And the reason why that ends up being a problem is if you forget to divide out the 3, your numbers end up being enormous. You end up with really huge numbers. So if you end up with really huge numbers, you probably forgot to divide that out. Are you okay? Yeah, you don't do the X's in there. All right, so I'm gonna use my other color, or you can leave a little gap and put your equals 7. We're gonna divide by 2 and square. So 4 divided by 2 and then square it is 4. Now, you're not gonna write plus 4 on this side though, because it is actually a 3 times 4. So it's 12. So just be careful with that. I know you can do 3 times 4. It's not hard. You just got to be careful. So it's going to be 3 times blank squared. What goes in the blank? X plus 2. On the right side, what is that, 19? Now that's what we did last class. We're going to just keep going. You just have to finish it up. What would you do to both sides? We got 3 more steps.
So divide by 3.
Divide by 3. Now, 19 won't divide by 3 nicely, so guess what? We're going to just leave it like that. 19 thirds. Don't discriminate. It's a great number. People get upset that it's 19 thirds. That's why I say don't discriminate. 19 thirds? What did 19 thirds do to you? It's fine. All right, then what? What are you going to put in front of it? Perfect. Plus and minus square root of 19 thirds. Yeah, nothing wrong with that. It's fine. Welcome to advanced math. By the end of pre-calc, if people get a nice answer, I've actually had people come up to me during a test. I got just 3 for this answer. I think I did something wrong. Like we get so used to like the messy answers. Just whatever you get is whatever you get. And then what's your last step? And then you're going to write it this way. -2 plus and minus square root of 19 thirds. Now we have one more method. Again, unless being told in the directions use the quadratic formula, I get that you're probably never going to choose this method on your own. But just to cover all of our bases again, I'm just going to show it to you because it's true and it's part of the material. So you know it because you came and brought it up to me. Let me see if I can pull this out of the rest of you. Does anyone know how it starts? It's -b plus or minus big old square root. You guys know it. All over 2a. Nice. Write it down. You're gonna be okay.
It's not even that bad. Wait, plus or minus. You got this.
Now, what I always tell everybody to do is, this is not about intelligence. It's about organization, okay? Anybody can throw numbers into a formula, but you have to stay organized. Write out your A, B, and C. I know that sounds really basic and silly, and I know half of you, Miss Cole, I'm not going to do that. That's fine. Like, just be really, really careful. And now we're going to plug it all in. So X equals -b. That would be -4 plus and minus gigantic square root b squared. That would be 4 squared, which is 16, minus, now we've got 4 times a times c. So 4 times 2, 8. Trying to walk you through it. 4 times 2 would be 8, and then times 3, 24. 4ac, 4 times 2 times 3. All right, and then it's all over 2 times a. So 2 times 2 is 4. And then you just kind of have to boil that down and simplify it. So it's -4 plus and minus square root. What do we get underneath there? 16 take away 24. -8, good. Over 4. Now I'm going to write this off to the side. We have to split up that square root of -8. So what do you take out first? -1. And then what multiplies together to be 8? 4 and 2. I just usually do that as a side problem, so I don't have to copy the whole thing all over again. So it is -4 plus and minus 2 I square root of 2, good, over 4. Hold on, I lost you. Square root of 4 is 2. Square root of -1 is I.
Oh, wait, the -4 stayed the same on that.
Oh yeah, I just kind of brought that down. That just stayed the same. All right, and then the last step is you divide these both by 4. So -4 divided by 4, -1, plus and minus. Now this would be 2/4, which would reduce to 1/2 I squared, which is a great answer. Don't discriminate.
So we don't do it to.
No, you can never touch what's underneath the root. That's kind of stuck in there.